Okay, so we are finishing up Chapter 5, Section C. And we already talked about the first part of this. We made frequency tables. We talked about qualitative versus quantitative data. Um, we even got into our bar chart here and how you should label things. So we're on example 4. And on example 4, it says that the carbon dioxide is released to the atmosphere primarily by combustion of fossil fuels, oil, coal, natural gas. The table lists the 8 countries that emit the most carbon dioxide. We're going to make bar graphs for the total emissions and the emissions per person. And we're going to put the bar graphs in descending order of size. So descending means would be the greatest to the smallest. So we're comparing two things. The first graph that I have here, and I've already posted these completed notes, but the first thing that I did here was I looked at the total CO2 emissions in millions of metric tons. And so that's why this is the left side of this graph is labeled total CO2 emissions, millions of metric tons. Across the bottom, I've got my countries. I had to kind of decide upon a scale that I would go by. And I looked at this, and the smallest one was 601. The biggest one is 10,000. So I knew I needed to get up at least to 10,000 and to 11,000 in order to fit this number. So that's kind of how I chose to do that. I went by 1000s, but I only labeled every other one because it would look so squished if I labeled every one, right? If I put 1,000 and 3,000 in there, there's nothing wrong with doing that, but it makes it a little bit easier to read whenever it's done like that, when you skip one, so it's not so squished. So I've got my title of my graph. I've got my left axis labeled. I've got my right axis labeled, and this is in descending order because you can see the bars are going steadily down. Because if I looked at these bars without these numbers being written here, I wouldn't be able to, in other words, if I didn't know this was 10,357 and I didn't have this chart and all I had was the bar, I would know, okay, it looks like it's a little bit over 10,000. And that's why I go ahead and write the number on there so that if you want to know the exact answer, you would be able to find it. And when I got down here, these just became so small that I could hardly put them in there. So I just wrote them above. So the other thing that's important is that this is in millions of metric tons. So make sure that you actually label your graph as to what it is, what you're talking about. I'm gonna see if I can blow this up just a little bit. So on the second bar graph that we've got per person CO2 emissions. Now, I don't know if this data is actually correct. And the reason that I'm suspect of whether this data is actually correct is because of this second graph. I mean, it's saying that Saudi Arabia, which is actually one of the smaller populated nations, according to this, is giving the most CO2 emissions per metric ton. So per person, okay? So that, I mean, probably because they don't have as many restrictions there on their pollution and things like that, but still they've got one of the smaller populations, but one of the bigger contributions to per metric ton per their population of, the second one's per person CO2 emissions. And so that's kind of suspect. The US doesn't really surprise me that because we do have a very large population that our per population would be bigger. But here's what I would probably don't agree with. Russia and China's way down here. I'm not trying to be ugly. I'll actually try to pull a better data of this because I don't know when this was taken, 2015, but China is not at all concerned about CO2 emissions. They're concerned about making money. So I don't know that this data is right, but you can tell like that from this Saudi Arabia obviously would have a real big problem because It's a very, like, as far as the land goes, it's very small compared to the United States, but yet they've got this much pollution per person, 19.4 metric tons per person. That's kind of crazy. So if I was comparing those two things, I would notice that. But that's how you would label those graphs. Okay. If you want to draw a pie chart, okay, which I'm not going to make you draw a pie chart, but you need to kind of know where they come from. This is talking about your grades, or so somebody's grades in their class. So the first thing they did was they wrote down the frequencies, which we know, and I am going fast on this. I did post these completed notes, Yolanda, because I don't want you to have to.
Yeah, no.
If I were to do this actually in class and draw all this out, it would have taken me 2 hours. So I don't expect that you're going to be able to write all this stuff this fast. But anyway, so to figure out the frequency, they gave us those. So I had, if this was my class, I would have had 4 people that made an A, 7 people that made a B, 9 that made a C, for a total of 25 people. Okay, if I want to find the relative frequency, which we talked about on the first graph, we would want to do 4 divided by 25, 7 divided by 25. We're finding those decimal numbers. Now, if I wanted to take these decimal numbers and turn them into percents, I'm going to have to multiply by 100. Okay, like 0.16 would be 16%, but it didn't ask me to do that here, so I'm just going to leave them. So when you want to draw a circle graph, you have to figure out, well, how many degrees of the circle is taken up by each one of these things. So there's 360 degrees in a circle. So they took their relative frequency, which was 0.16 times 360 to get 57.6 degrees. Okay, 7 divided by 25, they got 0.28, so they multiplied by 360 to get how many degrees that would take up. And if you were actually doing this by hand, you would have a protractor, which is one of those circle or half circle looking things, right, that has angle measurements on it. So this would be your 90 degrees. This would be 45 degrees, this would be 135, and this would be 180. And you would line up that protractor and draw these things out, okay? And that's probably what they've done here. So if you'll look, the A's were 57.6%. So if you kind of drew, just to put this in perspective, 90 degrees should take up about 1/4 of this circle. So 90 degrees should be about this if I were to draw it. Okay, and so they're saying that this is 57.6 degrees, which is 16%, which does make sense. It's definite, 57.6 is definitely less than 90. So it didn't take up all of the 90 degree slot, right? But it did take up a big portion of it. Okay, so C, if you look at the people that made C's, that was supposed to be 129.6 degrees. So if we drew a 90 degree angle right here, so I'm just using this side just to put this in perspective. If I drew a 90 degree angle, a right angle, right? Well, this C is supposed to be bigger than 90. In fact, it's supposed to be 129.6. So all the way around, it went to 90 and then it went extra to get our 129.6 degrees, okay? You're not gonna have to draw one of these with a protractor, but you do need to be able to kind of think about, okay, that's 90 degrees and that measurement is a little bit less than 90. So we've come down here and we've made a real easy example that we didn't have to use a protractor for, because it says that among the registered voters in Rochester County, 25% are Democrats, 25% are Republicans, and 50% are independent. So they say construct a pie chart to represent the party affiliations. So 25%, so 0.25 times 360 gives you 90 degrees, which does make sense because 25% would be 1/4 of the circle, right? So we got 1/4 of the circle that would be Democrats, 1/4 of the circle that would be Republicans, and then 50% of the circle is supposed to be independents, which would be your 180 degrees. So there's just a real short, easy example of how a pie chart is supposed to work. So we've got they're wanting us to compare a histogram or a bar graph. They're wanting us to compare it to a line chart. So these are the exact same two pieces of information. Okay, and I got the information. They already had the bins drawn for me, right? 20 to 29, 30 to 39, 40 to 49. They already had those bins drawn for me and the numbers up here. So when I did this, I went down and I kept the bins exactly like they had them, 20 to 30. That category was really 20 to 29. But when you're drawing a histogram, you connect them all. So then you start with whatever category, then you go, so 20, 30, 40, 50, and I did this exact same thing down here. Okay, so these were the actual ages of the women when they won the Oscar. Okay, and on the left side of the chart, you've got the frequency, which is how many times it happened. So this bar right here means that 32 women that were in the ages of 20 to 39, or when they were in the ages of 20 to 29, won an Oscar. This bar right here means 34 women when they were in the ages from 30 to 40 to 30 to 39 won an Oscar, right? So looks like that it drops off drastically for the older women if they're going to have a chance of winning an Oscar. I have always said that my dream job when I get to be really old would be to go to Silver Dollar City and be one of those like people that like shoot the fake guns, and like, wouldn't that be cool? Play with little kids. And so I think I'm gonna win one of these Oscars down here when I'm like 70 something. I'll be that one person that wins, maybe. But when you're doing a line graph, so the way that I got this is between 20 and 30. So I went halfway in between 20 and 30 and put my dot that was 32. For 30 to 40, I went halfway in between 30 and 40, or I tried to, and that would be my 34. Because you can't really, and so we're starting at 0. Between 40 and 50, that would be my dot that was about 14, and I went halfway in between to get those. So that's kind of how you do a line graph. Okay. But here's 2 more examples. One's a histogram and one is a line graph. So 2 more, and I think that paper probably should have come first, but it just gives you an example of how you would draw it. Okay. So our very last thing that we're looking at today is example 7, and this is just asking us to make some kind of statement. It says to briefly summarize what's shown. So we're not wanting a lot of detail, but if I were to look at this graph, I see some things. I see this is talking about U.S. homicide rates. It's important that I know what I'm talking about. Okay, and this is homicides per 100,000 people. My graph's labeled 4, 6, 8, 10, 12. One thing I'm noticing is that from the beginning, from 1960 to about right in here, it looks like we're on an upward tick. So I put down that one thing I've noticed is there's a drastic increase in homicide rates in the years 1960 to, this looked to me like about 1974. Then this little section to about right here, to me, kind of, well, we're going up and down, but we're kind of staying in a steady kind of range. We're going up and down, but we're not, nothing like we had here and nothing like we're going to have at the end. So I said that the homicide rates seem to level off from 1974 to 1994, which means they're kind of staying steady. There is some increasing and decreasing, but not anything as drastic as what you're seeing from 1994 to 2012. It looks like there's drastic decrease in crime rates. Now, if we were trying to get more specific, but this says to briefly summarize what's going on. We could get a lot more specific in this. If I was going to get really specific, I might have focused on what happened during this period, because it looks like we went down, then back up. Was there some kind of legislation or, that caused that to happen? I mean, we could have focused on some of that stuff and got a little bit more specific, but that's what, if it's asking you to analyze a graph, that's what it's basically trying to get you to do. So that is the end of 5C. Next week in class, we'll be talking about 5E, and we'll be doing 6A. And those videos will be posted as soon as I get done teaching them and get them uploaded.